When liquid bromine is produced from the reaction involving a bromine-containing binary ionic compound, the half reaction leading to the formation of Br2 is classified as A. Oxidation, B. Reduction, or C. Oxidation or reduction depending on what the compound is. A binary ionic compound is a compound derived from a metallic element and a non-metallic element. The positive ions or cations in a binary ionic compound comes from atoms of the metallic element, and the negative ions or anions come from the non-metallic element such as bromine. Since bromine is a non-metallic element, the anions in a bromine-containing binary ionic compound must come from bromine. Indeed, the bromine in such a compound are known to be bromide ions, which have a -1 charge. Bromine is a halogen. If we refer to a periodic table, we find that it belongs to group 7A. The naturally occurring monatomic ions from this group are always found to have a -1 charge. Therefore, the question is essentially this: is the production of diatomic bromine molecules from a bromide ions considered as oxidation or reduction? The answer is oxidation, choice A. Because the process involves a loss of electrons is defined as oxidation. The opposite of oxidation, gain of electrons, is reduction. Here's a symbolic representation for the conversion of bromide ions to diatomic bromine molecules. A bromine molecule is electrically neutral. Since we are starting with two bromide ions, each with a -1 charge, we indicate that the two negative charges are carried away by two electrons. Here's an example of a reaction described in this question: the decomposition of sodium bromide into sodium and liquid bromine. Here's another example, which involves single displacement. When bromide is displaced from an ionic compound to yield diatomic bromine, the formation of bromine is called the oxidation half reaction. In general, anytime you convert monatomic anion to a neutral atom or molecule, like a diatomic bromine molecule, all electrons are lost and the process is classified as oxidation.